Welcome to this section on packages. The two packages we shall be looking at are Numpy and Matplotlib. To install this, you just have pip install Numpy, and then to use it, you could have simply Numpy as np. Numpy is a high performance computing library. Let's see how to create a simple Numpy array. So we have that, we have a equals np.array. Obviously we've imported numpy as np, so everywhere we have numpy we simply use np. Numpy.array, let's have this one-dimensional list pass in. There we go, we have that. We could now print out a, and that's it. That's our numpy array. We could also define a two-dimensional array, say b np.array. We have this two-dimensional array 0, -1, then 6. We could also specify the data type. So here, let's put this right here, specify the data type, say it's float. So run that. Let's check on this. We're supposed to have a comma right here. Run that. Now let's print out b, which is our two-dimensional array. We see that it's made of 3 rows and 1, 2, 3, 4, 5 columns. If you do a b.shape, see we have 3 rows, 5 columns. It's very important to always come up or get these shapes, because when debugging your code, getting to know a given array's shape is very important. Note that a simple list, say like this, if you have to print out a.shape, you will have this error. List has no attribute shape. Now if you have numpy.array, see that works. Now we could print out the numpy.array, which takes an a. So this now is a numpy array which is basically made of this list, but this one has the advantage that we could make use of numpy's methods and properties. We could also create a 0 array. So we have here a np.zeros, and then once you want to create this kind of array, you just need to specify the shape. See here we have an error, which is very common. Make sure that you put this as a tuple, so we should have that. So specifying this, we have this shape here, and that's fine. Now we could print out a, and there we go. We have this 3 rows and then 5 columns. Could have say 8. See the difference? We have 1, that's it. And if you have any problem understanding the row column notations, you could check out on our linear algebra course. Apart from the zeros, we could also have ones, so just like that. There we go. If you want to have a particular number, you could just simply take 5 by that and all this. So we have 5 times all the ones, so this is what we get. We have 15. And basically that's it. We could also create an array which goes from one value to another. So we have len space. Now as the word goes, we have len space. So we are going to go from say 3 to 9 while giving a space of say 2. Let's print out a. We have this 3, 9. Now actually what this does is similar to the arrange, but there's a difference. Let's take this off and then have arrange. Run that. Take one R off. Okay, so this is the np.arrange, and here's the np.len space. For the two methods, we're going from this initial position to this final position. For the len space, we'll define the number of different values we shall take. So since we've decided to work with only 2 values, we start with 3 and obviously we end with 9 since we were working with 2 values. Now if we go to 3 values, you would have another value coming up in the middle. So here we have 3, 6, 9. If you go to 4 values, so you have 3, 5, 7, 9. So basically what this does is it takes 9 minus 3, it gives us 6, and it tries to break it up or break this sequence up such that we have 4 different points. If we continue increasing, you see we have to work with decimals. So that's it. Now we have for the arrange, we are not defining the number of points we shall have in our list or the number of elements we shall have in our list. With this, instead, what we're defining is a step between each element. So if we say we have a step 2, so when we start with 3 plus 2 we go to 5, plus 2 we go to 7, and then we don't also take in the last element. So that's why we have this 3, 5, 7. Let's modify this to say a step of 1. You see we go 3, 4, 5, 6, 7, 8, and then we don't take the last. This too is similar to the range function, where if we have from say 3 to 9, and we specify that we want 2. If we have that, let's print this out. See we have 3, 9, 2, and we have for I in range 3, 9, 2. We could print out I, and there we go, we have 3, 5, 7, which is similar to what we had here. We could also create an identity matrix very easily. Suppose we have this, we have np.I, we have the shape, takes that 5 by 5. We told that doesn't take that, so let's pass it this way, print out A, still this error, so it means we need to pass the shape simply like that. So with the I, instead of having to put the shape as a tuple, we just have to pass it this way. We could pass it like this simply, unlike with the zeros where it was a 0 we had here, where if we just have say that, you see we have an error. So let's get back to this. With the I, we could run it like that, and then we have this identity metric with 1s in this diagonal, and all the other positions are 0s. We could also create an empty array, so we could say mp.empty, say 3, 3, print out A. Just like with the 0s, we need to specify this. So that's it. Then many times we shall be working with random numbers, so you could have np.random, say 4. Let's have that. See we have this random numbers which are generated. Now we could specify the shape, say 4, 5, and there we go. Now we have seen many of these operations or these methods called on a single array. Let's suppose we define this array, np.array. Let's just copy from this here. So we'll define this array. Take this. Here we have A, which is this array. Could print out A shape 3 by 5. Let's define B. Now B could be a random array, random. Let's take this off. Random, specify the shape, say 3 by 5 too. So that's it. Now we have this random array 3 by 5, 3 by 5, and here we have B. So now let's print out A plus B. This doesn't take shape, so let's take that off. Okay, that's fine. Now adding up this 2 is just like simple matrix addition. You see that we just take it's an element wise addition where this element added on to this corresponding element in the B array and all the rest follow. So that's it. Now if we had, for example, zeros here, let's say we had zeros, run that, you see that this array is going to be maintained because basically we're adding this with zeros. If we say we want ones, you notice we have 3 plus 1 4, 4 plus 1 5, 6 plus 1 7, so on and so forth. We could also subtract, so instead of this we could have subtraction, that's it. Then we could have division. See, it's an element wise division actually, so since this is ones, we would have this a maintained. And then if we had, for example, zeros here, see, we have all this infinite values because we are dividing this a real number by a zero. Now let's take this to ones, and we could also have multiply, so we could have run like that. There we go. Multiplying this with ones again maintains its value. It's element wise multiplication actually. Now if we want to do, we could also do numpy.add a and b, so we could do that. We could do numpy.subtract, we could do numpy.divide, we could do numpy.multiply. See, it's the same. Now this is all element wise operations. Now if we want to do the matrix multiplication that we know, and that's which actually different from this element wise multiplication, we have the mat mul. So run that, you see that we already have an error, and the reason why we have this error is because A shape is 3 5, and then B shape is 5, it's rather 3 5 2. Now note that, or recall that when doing matrix multiplication, the number of columns of the first matrix must be the same as the number of rows of the second matrix. So in this case 5 is not equals 3, that's why we have this error. And so to correct this, we could say, for example, we have to define this as the transpose of this, such that instead of having a shape 3 5, we'll have a shape 5 3, and in that case we will see that this two will be the same. And if these two are the same, then we would have an output of shape 3 3. So now let's run this and see that it works fine. So our output is of shape 3 3. We've done now a matrix multiplication on that. If we do multiply, see we have an error because the element wise multiplication cannot work when the two don't have exactly the same shape. Now apart from doing the transpose this way, we could define np.transpose. That's it, run that. Obviously now we need to do multiplication or metric multiplication, that's fine. There are also many common functions which come up, or which come with numpy, which we could use. Like for example, if we have a, this numpy array a, we could have a.sum. There we go, we have 95, telling us that the sum of all these elements equals 95. We could actually say, for example, let's define a to be equals np.ones of say 4 2. So in this case we will have 8 different positions, so the sum should give us 8. Run that, see we have a sum of 8. We could look for the minimum value, that should be 1. Look for the maximum value, that should be 1. We look for the mean, we look for the standard deviation. We could also do some sorting, so we could have sort. Let's print this out. A.sort. This actually does the sorting, so after doing the sorting, we could now print out A actually. So that's it. Now let's define, let's say we have this, let's take this off. Let's say we have this np.array for 1 0 -4. Yeah, that's fine. Now let's sort it and then print it out. So after sorting, we see that it's actually correctly sorted. And also, instead of doing it this way, we could just directly print out np.sort of A. So run that, we see it's correct sorted. Now we could also use the arc sort. With this arc sort, let's print out the sort, np.sort of A. And then okay, let's do the arc sort, the sort before the arc sort. Okay, let's run that way. So now we've done the sorting. What the arc sort does is it actually looks at the positions, or the position that is -4 occupied initially. So like after sorting, we see that the -4 comes to the first position. So we see that in the first position we're putting out the 3. This 3 here simply says this, or after sorting, the first position will be occupied by the value which initially was on the 3rd position, and then the 0th position, because there's 0, 0, 1, 2, 3. So the 0th position will be occupied by the value which was initially on the 3rd position, 0, 1, 2, 3, -4. That's it. And then here, this first position will be occupied by the value which was initially on the 2nd position, 0, 1, 2. That's why we have that 0. It was initially the 2nd position. So that's how we look at it. With the arc sort, we look at your previous position. With the sort, we actually look at you, or we actually look at the number or the element in question. Another important method is the reshape. So let's come back to this. Let's use this. So supposing we have this array, we've printed it already, the shape 3, 5, and then we want to reshape this to say 5, 3. What we could have here is np the reshape of A, and then we specify the shape. So we specify the new shape. We want this new shape to be 5, 3. We want it to go from 3, 5 to 5, 3. There's no keyword shape. Take that off, and that's it. Now let's print out the shape of this new. So we have here 5, 3. Now note that if we say, for example, want to have a new shape 5, 4, that should give us an error, and this is normal because first of all, this initial array of dimension of shape 3, 5 has 15 different positions. 1, 2, 3, 4, 5 times 3, giving us 15 positions, whereas this new array has 20 positions. So it's not possible that we do a reshape such that there will be a match between this initial array and its reshaped array. So that's why that doesn't work. We have 3, we run that, we see that we now have 3, 4, 6. That's the first row, 3, 4, 6. Here, this is like the first row, then 0, -1, 56, and that's it. Follows that. We could also say here we want to put -1. Now if we put -1, what happens here is NumPy is going to automatically get this value for you. So many times when we want to carry out this kind of operations, putting a -1, it just says we give NumPy the liberty to tell us what value is best for us here. So if we do this, see, it gives the same answer. Print out that shape. That's it. Now if we had, instead of that, if we had 3, let's not take 3. Suppose we had, let's add this, because apart from 3 there's no other value. Obviously if you put 3, this is going to give you 5. It calculates automatically for you. If you put, say, 2, no matter what you put here, see, you must have an error, because obviously having 2 means we're going to have an even number of possibilities or number of elements, and here already we have an odd number, so it's not possible that we reshape this into an even number. Take that back. That's fine. Another method is the concatenate method. So suppose we have this here, let's make it simple. We have here 4, and then we have the B and P dot array, which takes in maybe just 5. Now we could have np.concatenate A and B. Let's run that. Let's modify this, put a triple. That should be fine now. Run it, and there we go. We see how we concatenate this. We have 654, and then this is added on it. Now let's specify the axis. Like normally by default this axis is 0. Now saying that 0 simply means, let's take this a.shape. Okay, by saying that 0 simply means the concatenation of these two arrays is done on the 0th axis, which in this case is the lone axis. Now in this kind of array, this 2D array right here, we will not have just one axis. Let's print this twice. We have here A and B. Now let's take off some of those elements. We have 3, let's even go to 2. So it's a 3 by 2 array that we have for B, and this is 5 by 3. We could print this out. So we have a.shape, print b.shape. There we go. 3 5 3 2. Now let's do the concatenation and see what we get. Print out the np.concatenate of A and B. Now by default, as we said, if you don't specify the axis, that the default axis is 0. So let's run this. We have this error, which is normal. Now let's understand what's going on. When doing concatenation, what goes on is that the axis, like in this case, the axis is actually 0. So even if we do axis equals 0, we'll still have this error because by default the axis is set to 0. So when doing concatenation, as we're saying, here we have this axis, or we specify axis 0. So what goes on is these two are somehow fixed, and then what NumPy tries to check now is to ensure that the other axes are the same. So if we want to concatenate this two on the 0th axis, then we fix the 0th axis. That's, yeah, we fix this, and then we verify if these two are the same. If they're not the same, then we cannot do the concatenation. So just like with this, when we fix the 0th axis, we see that actually there's no other axis, so we could simply, the concatenation was possible. But here, where the axis, where we have this first axis and this first axis here, they are both different, so we cannot, the concatenation cannot be done. Now another way of looking at this is by saying that if you have this array, the shape is given in as the row and the column. So if we have an array A, the shape is row column. Now if by default the axis is 0, it means you are doing concatenation across the row. Now if you look at those rows here, we are having to concatenate this row with this other one, and to do this, the number of elements we have here must match up with the number of elements we have here. Same with this, you see we have to concatenate this two, the two elements or number of elements must match. With this other example here, we have actually no row and no column because this is one dimensional, and since it's one dimensional, we could just simply just pack this or add this to the end right here. But now we're dealing with a two-dimensional array. We have to be very careful with the way we do the concatenations. So here this cannot be concatenated on this. This two can't be concatenated, and this two. Now if we want this to actually work, we must ensure that for a given axis we are fixing, like if we work with the first axis, that's we fix this and we fix this, the other axis must be the same. So in this case, for example, we see that 3 is the same as 3, so this should work. Now looking at this in another way, we'll see here that if we have to concatenate this 2 through the columns, then we'll have 3 56 0, which is going to be added here, and then 440 added again. So let's run this so you could see that clearly. We have 3460 -1, this part, and we have this 3560 which is added, this line here, and then we have 440 which is added. So here we concatenate this array with this other one. Now let's go ahead and modify this again. Suppose we have now 2, so let's come like this. Now we have 2, run it, see we have an error. If we go to 0, we'll see have an error. It's impossible to do the concatenation. So to do the concatenation, the axis we select is fixed, and we monitor the other axis to be sure that the concatenation is possible. Also, apart from the 2D arrays and the 1D arrays, we could also define 3-dimensional arrays. Let's copy this, paste this out here. Now, if we have to define a 3-dimensional array, then we'll need to add another axis. So let's put it this way. This is seen as regrouping 2-dimensional arrays. As you could see with the 2-dimensional array, we're regrouping this 1D arrays, this one, and this one, and they're seen as columns, or rather just seen as rows here. This is one row, another row. But with 3D arrays, this 2D array is going to be seen as one line in our 3D array. So like this, we add that. There we go. This is our 2D array. So we have this 2D array right here, and then let's copy this again. So that's the first line, the next line. So this our first line 2D, next line 2D. Just like with a 2D array, we had this line 1D, 1D, 1D. For the 1D, we had just an element. Coming to the 2D, to the 3D, we have 2D, and so we could have this. There we go. So now we have this 1, 2, 3, 4, 5, 6. We'll stop there. That's fine. So now we have this, and then we could close it up right here. Let's close it up here, so we could close it up there, and that's fine. So now we've defined this. Let's have that. Okay, so we define our 3D array. We could print out the shape. Now looking at this, we have 1, 2, 3, 4, 5, 6, and then for each of this, so we should have 6, and then for each of the 6, we have 1, 2, 3 by 5, so it's 6, 3, 5. Let's comment this and print out the shape. There we go. We have 6, 3, 5, telling us that we have 6 different 3 by 5 2D arrays. Again, here, if we have to do concatenation, suppose we have, let's take this for example, let's reduce this, or we could print this out. We could take this. We have here B, and then we take just 2 of this. Okay, so we have just 2 of this. We could print out a shape, B shape. So we have B that shape. There we go. 2, 3, 5, 6, 3, 5. Now, as you could see here, if we're doing a concatenation, so we could print out np.concatenate of A, B. Now, in this case, it's going to work because if by default the axis is 0. If the axis is 0 by default, it means we're fixing this and fixing this. Then we are going to look at the other part. So we're going to look at this 2D array and compare with the dimension of this 2D array. So if the shape is the same as the shape, then the concatenation is possible, like in this case. So we could run that, get this error, let's pass this properly, and that's fine. Now we have this, we could monitor the shape. So we have here shape. Let's actually print the shape before. So we have this. Okay, we have 8 by 3 by 5. So the concatenation has been done on this zeroth axis. Now if you have to do that on the first axis, so if we have axis equals 1, you see normally that shouldn't work because fixing this axis, the 6 5 doesn't match with 2 5, so that wouldn't work. Now if we have to do on the second axis, it shouldn't work too, because fixing this 6 3 doesn't match with 2 3. But then if we take this off, so if we take some of this off, let's take this off, run that, run it, see now it works, because when we fix this second axis, 2 3 matches with 2 3, so that's fine. Now even if we don't have 5 elements, so even if we have, say for this one we could have say 4 elements, 4 4 4 4, run it, see here we have 4 elements for each of these 2D arrays, so we have 4 columns for each of the 2D arrays. Now if we fix the second axis, it's still going to work. Here we have this error because the axis here was 0. Now let's have this axis equals 2. See, that works fine. The shape is 2 3 9. We've fixed the second, and then we've compared this first 2 axes. They are the same, so the concatenation is possible. Now also when given an array, say we're given this array, let's take this 2D array here. When given this kind of array, we could get specific elements depending on their positions. So if we have this A, we could say we want to get A0. Now A0 corresponds to the 0th row, so that should correspond to this. Running that, you see we have 3 4 6 0 -1. Now if we want 1, see it works. We want 2, we have this last one. Doing 3 should throw an error, so because we actually have 3 rows, so we should go from 0 1, we should have 0 1 and 2. So that's it. Now if we want to be more specific, we could have 1 and then 0, meaning that we're going the 0 1, that's first row, and then the 0th column, so that's 56. And that, say we have 56. If we select 3, see we have 6. Select 8, see we have an error. Let's get back to this. 3 0 1 0 1 2 3 6. So that's why we have 6 here. Another easier way of doing this is by using the comma. So we have 1 comma 3, the first row and the 3rd column, so we have the same answer. Also using the same comma notation, we could have, or we could select the first row, for example. Now in order to select the first row while selecting all the elements in the columns, we could use the colon. By putting this colon, we just simply saying all, so basically this is equals to saying all columns. Now the column is obviously different from the columns, so we have that columns. So we having 1 that, see we have 56, that's the first row, the first row. This is 0th row, first row, second row. Now we could pick out the second. See, basically what we're saying is that take the second row and all its columns. Now if we say 0, it means take the second row and the 0th column. So second row 0 column will restrain to only this value. That's why you see we have just one value. So we'll do that, that's fine. Now we could also decide to work with only the columns. So we have that, let's say we have 4. Now we're having all the rows but only the 4th column, so we go 0 1 2 3 4. That's actually the last column. Run that, see we have -1 6 2, -1 6 2. Let's actually print this out. Let's print out A so it appears, looks better. That's it, -1 6 2. That's fine. We could do some slicing. With slicing, let's take this 1D array, take it, put it out here. Now let's increase this 6 1 2 1 6 9 8. That's fine. We can now print out the A, but now we actually slice it out. So we could say we want to work from 1 right up to 4. See, we go 0 1, that's it, 2 3 4, so we'll go 5 4 6 1. But in this, with this notation, what it's saying is go from the start to the index minus 1. So that's why we have 4, we have 5, we have 4, we have 6, but we don't take 1 into consideration, although normally this is like 0 1 2 3, let's take that, 3, yeah, 4, and then 5, and then the rest. So here we having 1 to 4, means we're taking this 1 to 4, but we're not taking the last index, so we just end here, and this corresponds to 5 4 6. That's it. We could also do 0 to 4. See, we have, comment that, see, we have 6 now, we have all this, 0 to say 9, there we go. Then we could say we want to take all the first 9 elements, so instead of specifying 0, we just do that, and it starts from the 0th position. Now if we want to go from a given position to the last position, we just do that, and it takes from 4, that's the second, 4 6 1 2 1 6 9 8, that's it. Let's print out A so we see that clearly. So that's it. We actually take this 4, we could do this 5, you see it matches up with the first 5 elements. Then if we do a -1, what we're saying here is start from the first element and then go right up to the last. Now going right up to the last simply means we're gonna go right up to the last -1 index. That's why we have this right here. If we want to have -2, see, we go right up to the last but 1 index, so we actually end up here. But since it's index -1, we end up now with this, so we go from 6 5 4 6 1 2 1, and we end up at 6. We could replace this now. I'm putting this to the array. Run again. You see, we let's print. So now we have this to the array A. We're taking all the elements. Let's say we take all the elements from the, we take the first element to the second element. It's basically saying we're taking the first row, we're taking the 0th row, we're taking the first row, and that's it. That's why we have this row, and then this row we don't take this one because we're going up to index -1, or this n index -1. Now we having that, we've seen that clearly. We could now have, say, 0, or we could say 1 to the n, or we just have 2. Let's say we have 2 to the n. See, we take this only now. We could have 1 to the n, take that. We could have all, that's fine. It's the same as having A, obviously, so that's it. We will have all the rows, but now we decide to pick the columns, so we could say go from 2 to 3. See that? We could take 4, let's say 4, close that, run it. Okay, now what we're doing here is we're saying for the rows, take all the rows, work with all the rows, so work with this row, and this row. But for the columns, work with the second column, or work with the from the second column to the 4th column. And obviously, since we're going up to index -1, we're working with the second column and the 3rd column. That's 2 and 3, since we're not including 4. So that's why we go 0. Let's print this A. We go 0 1 2, that's second, and then the 3rd, this, that's fine. So we have 6 0 5 6 3 1, and that's what we get here. This is similar to doing this. We could have, say, 1 2 2, and then take all the columns, run that. You see, we have that. Yeah, we're picking out the first, or we take 0. We don't take 0, we actually take 1. We end there because we're going up to 2, so we just have to end there. We could obviously take 3, so that we could take the second, or yeah, we could take the second row, 0 first and second. So we have 1 2, but for the columns we take all the columns. We could also go ahead and specify that we want to take the first 2 columns, so we could have 2, have that like that. So we have the 1 and 2 for the rows, row 1 and 2. So we have this row and this row, and in this row 1 and 2 we have the first 2 columns. So we have this, let's take from this, we have row 1, row 2. For the columns we have up to the second, so we go 0, 1, 2. Now that we are not including this last index, we go from 0 and 1, and then if we're going 1, 2, 3, we having the first and the second row. There's the first and the second, and then in this first and second we're picking out the 0th and the first column. So we have 0 and first. The intersection happens to be the 56,400. Running this, we have the 56,400. Now we could also say, if we want to have all this, yeah, we could run it like that. We pick out first 1 to 3 for the rows, and then we have all the columns. Apart from doing this, we could use 3 dots. This 3 dots simply means take all for all the remaining axes. Now that we have just one axis here, that's once we pick out this row axis, we left only with the column axis. So basically we just have one axis here remaining. So we're saying that take all for all the remaining axes, so we should have the same results. Now let's work with 3D input. Let's come to, we had this 3, okay, yeah, we had our 3D input here. We take this off, take that off. We have A, and now we print this. Let's take this off from here. It's not, yeah, that's it. So we have this A here. We take this off too. Run that. For now, let's just have this. So for now, we have in the first, as we go from 1 up to 3, we print that A. Here's A. So A is equals this. That's A. Let's just take this off so it could look better. So A, this A, and then here is this selected or sliced version of A. In this version, what we're doing is we're taking out, given that A, let's look at A shape. Let's print out A shape so it's clear. Shape. In this version, we're working with the first and the second axis for this first dimension, because we have the first dimension, second and the third dimension. So we're working here with the first and the second axis, obviously, because we're gonna go up to index. We'll go up to index -1. And so if we look at this here, working with the first and second simply means this is the 0th, then this is the first. So we're working with this, and clearly this is the output we get. Now if after picking out this output we want to get more specific, say we want to get the 0th output. So after picking this out, we want to get a 0th output. We could have 0. Run that again. There we go. We have this 3, 4, 6, 0, -1. So after picking out this first, we take the 0th. That's now the 0th row here. 0, 1, 2, 3. If you want to take the first 2, we could have 0 up to 1, no, up to 2, because we have 0 and 1. So run that. You see we have this and this. Now we could also pick, we could obviously pick from the beginning. So if we pick from the beginning here, you see that with this we pick all this, we pick this 1, 0, and then we also pick 1. That's the essence of this. Then in this, for this specific one, we pick the 0 up to 2. So that's why we have 0 and 1. That's it here. Then for the next one, we also pick 0 and 1. Now if we have just 1 here, see, pick just this 0. Here we pick out just 0. If we take this to 1, see, we pick now just 1, because we're picking out axis, the first axis for the 0, or we could call it the 0 axis. For the 0th axis, we're picking the values from 1 to 3. So here we started, we're not going to take this 0th axis, we're going to start with 1, and then in this 1 we're now going to work from 0 to 1 again. So we just pick out just this 1. Now if we get in this 1, we want to pick out a given element. We could say we want to pick out, say, the second element. So we'll pick out this, and then we'll go 0, 1, 2. That will be 6 on this. So that's it, we have 6. Now we could also pick out a slice in this. So we could go from 2 to 4. So 0, 1, 2, 2, and 6 and 0. Should have 6 and 0. Now forgetting that, we could obviously put this to say we want to pick all. Picking all here means we're working with all the different columns. Now we could also use the 3 dots, gives the same answer. Another interesting work we will do here is, in the case where we want to do this, let's say we want to have this all. This simply means we pick all of this. So we pick only the first axis. Let's just do this. Let's have this. We pick only the first axis, or we could pick only the 0th axis, which is now this. Let's make it different. Let's say we have 41, 1, 10, 10. So you see that difference now. So here we pick out the 0th, and then for the 0th we pick now all the rows and then all the columns. So that's why we have all this here, all this array printed out. Now if we want to do this simply, we could also have 3 dots. Now this 3 dots, as we said, means for the rest of the axis, take everything. So it's going to have the same